Okay, so we'll start the testing of this thermal relay. We'll take the first reading. So for that, first of all, I will switch on the main supply as per the procedure. Then I will switch on the 4-pole MCB for the kit. So now supply is reached to the kit, right? Now I will see that I have used 50 ampere tap here, common and 50, and my ASS is also 50 ampere, ammeter selector switch, and my CSS is also 50 ampere, right? Then I will switch on the current source. I will switch on the current source now here. Okay, and how much current I have to pass? I have to pass 2 times, means I have to pass 24 ampere current. I have set the relay for 12 ampere. Okay, so I am passing 24 ampere. See, I have passed 24 ampere and I have started the timer. Timer is started. I have passed 24 ampere. You can see 24 ampere. So 24 ampere current is now flowing through the thermal relay. Here timer is on. You can see the timing is recorded here in seconds. And here this 24 ampere I have passed. So after some time, this relay will trip. Okay, and what is the range of operation? Here we have seen the range is between 48 to 115 second. So between 48 to 115 second, this relay will operate. Then we can say that this relay is good or this relay is okay. Okay, so now let us see, 34 seconds have elapsed. Still the relay is not operated. The starting time begins with 48 second, right? So after 48, really its range of operation begins. Now it will operate after some time. See, this is 24 ampere and timing is still continued. This current 24 ampere is passing presently through all the 3 poles. So we are equally loaded all the 3 poles. So 3-pole loading test we are conducting here. All the 3 poles are equally overloaded by passing 24 ampere current. See now 1 minute. See, now I have stopped because relay is operated. So how much time I got? I got 1 minute and 16 seconds. So 1 minute and 16 seconds means how much? 60, 70, 76. So it is 76 seconds totally. So I will write here in the observation table 76. So see, the range is between 48 to 115 and relay operate at 76 seconds. So my relay is okay. See, the current automatically, as soon as relay gets operated, this current becomes 0. Okay, and I have freeze this timer and I note down that particular timing. Okay, so this is how we have completed our first reading. Now for second reading, we have to wait for 10 minutes till the biometer gets cooled, and then we will take the second reading by passing how much current? By passing 2.5 times of 12, that is 30 ampere current will pass, and again note down the time, right? Okay, so we'll take now the second reading. So for that again I will switch on the supply, switch on the 4-pole MCB. So supply is reached to the kit. Now we have to inject 2.5 times. 2.5 times means 30 ampere. Okay, so I will switch on the current source, variac, and how much current I have to pass? I have to pass 30 ampere, that is 2.5 into 12, that is 30 ampere, and once I pass 30 ampere I will immediately switch on the timer. So I have switched on the timer. So timing is started and we have passed 30 ampere through this MCB, through this thermal overload relay. Now what is the range of operation? It is 28 to 70. So between this range it will trip. Okay, 28 to 70. So see, now it is 30 ampere almost, and this is 20 seconds, 21 seconds, right? So it will trip now after some time. So see, now this timing is started. Now you can see this will trip after some time. Okay. So see, now it will trip after. Let us see. This will trip now. Yes. See, current is becoming 0, and this timing we got 46.73 seconds. So the thermal relay has tripped. So we have this 46 seconds. So we can note down this in the observation table. So we have the second reading. How much we got? We got 46. So this 46 is again between 28 to 70. So we can say our relay is again okay, right? So now we will wait again for 10 minutes and then we will take finally the last reading. right? So, okay, so we'll take the last third reading. So once again I will switch on the supply. MCB 4 pole I will switch on. And now how much current we have to pass? We have to pass 3 times the set value, that is 12 is the setting value, and 3 times of that, that is 36. So we have to pass 36 ampere of current, right? And what is the time range? Time range is 18 to 46 seconds, right? So I will inject now a current of 36 ampere. See, I will switch on the current source variant, and now how much current I have to inject? 36. So once I put it to 36, I will switch on the timer. So this is 36. I have switch on the timer. So timer is on now. I have injected 36 ampere through this thermal relay, and now thermal relay will operate within the range of 18 to 46 seconds, right? So it is 19 seconds, 20 seconds. Now it will trip now. Yes, so it is tripped. So 26 seconds I got, and this current becomes 0. Here this is operated, thermal relay is operated. It will auto reset. Just see, you will get a small click voice. So that is nothing but the voice of auto reset. Just listen that voice. Let us see whether we can catch or not. Yes, so this is auto reset, and I will note down this 26 seconds here in the observation table. 26 seconds. Okay, so all these 3 readings we got within the limits, and therefore I have written the remark actual trip time is within the limits, minimum maximum specified by the manufacturer, so a relay is okay. Same way the relay is tested for 14 ampere setting, for which we can pass 28 ampere, 35 ampere and 42 ampere current during the testing, and the actual time of tripping the thermal relay I got 95, 70 and 37 seconds. Now this is again within the limit as specified by the manufacturer, therefore I will write again the same remark here. The actual trip time is within the limit minimum maximum specified by manufacturer, so relay is okay. So in this way I will complete the testing of thermal overload relay for two different settings, 12 ampere and 14 ampere, and thereafter I am going to plot the characteristic. So I am going to plot which characteristic? I am going to plot current on x-axis against time on y-axis. So for this first setting of 12 ampere, I will get this particular curve. This is I am getting for 12 ampere, inverse curve, when I join these 3 points by smooth curve. Then for second 14 ampere, I will get another curve. So this is the curve I am getting for 14 ampere, and this is my 3 points, which when I join by smooth curve, I will get. So this is 14 ampere and this is for 12 ampere, the IT curve. So from this what we conclude, as the currents relay setting increases, the IT curve shifts upward and vice versa. So if you want the IT curve for 9 ampere, probably you will get it somewhere here, 9 ampere. If you want IT curve for 15 ampere, it will be somewhere here. So in this way the curve will shift upward as the relay setting increases and vice versa, right? So this is important conclusion we can draw from this particular experiment. And of course the application of this thermal overload relays, already I have told, protection of induction motor, to protect the induction motor against overloads, this thermal overload relay is used, right? So thank you.